All right. So yesterday we talked a little bit about isolating the variable. We're going to be doing it a little bit more today, but this time we're going to take a look at some more complex questions because yesterday we only had one step for a lot of the questions. So what if there's multiple steps, right? And so I'm going to teach you a new word. This word is called inverse. Now, inverse is actually the same thing as working backwards. So it's me saying, hey, what's the opposite of this? Okay, so working backwards or opposite. All right. It's similar to what we talked about yesterday. The idea is you want to do PEMDAS, but you are going to start with this first, then this, then this, then this. So if you see any addition, subtraction, you do that first, then you go and do the multiplication, division, then you do any exponents, and then you do any parentheses. Let's start with a more kind of a more straightforward question. So the example that I'm going to show you here is, what if we have something like 2x minus 3 is equal to, let's say, 7, all right? So now, just to give you context or like some kind of idea of which way we're going, you could still do this one potentially in your head. You'll see that the x is equal to 5, and how you do that is you kind of just brute force, like trial and error. What would x equal? If you do x equals 5, then you're going to see that this works. I'm giving you this because this is the answer that we're looking for, and I wanted to match it just to show you that this method, this style works, all right? So how would I solve this question? I start off by having a line like that, and then I look at the addition subtraction first. So this time, remember that you're still trying to isolate this variable right here. Actually, I'm going to put green on that. Remember that green is kind of optional to write down. But this is the side that I'm going to isolate, which means I have to start with the addition subtraction. In this case, it is the minus 3. And let's start working on that one. So if I have minus 3, I want to get rid of that. I'm going to do the opposite, which is plus 3. Remember that I have to do it to both sides. So then I can cross that, the one on the left side off. I'm left with 2x, and 7 plus 3 is equal to 10. Now, make the line a little bit longer. I'm going to divide this by 2 now. So I'll have to divide both sides by 2, just so I can get rid of the 2 on the left side. And then I'm left with x on the left side, and 10 divided by 2 is 5. Can't do anything more. X is already isolated, so then the x must be equal to 5. And if I take a look at this right here, ta-da, that is correct. All right, so good job. All right, so now I'm going to give you an example. Once you're done writing this question down, you could go ahead and pause this, but I'm going to make this one a little bit trickier, and let's see if we could solve this. Let's do 7 minus 3x is equal to, and let's do -5. Ooh, big tricky numbers there. All right, go ahead, give it a shot. See if you could solve this. Yeah. All right. So at this point, I'm going to go again. If you're still trying to solve it and this video is going, you could go ahead and pause it right now, but hit play when you're ready to see the answer. All right. So PEMDAS, I have to start with the addition subtraction, which in this case is 7 minus 3x. Now, this does get a little bit trickier because you're like, well, what do I do with the 7 here, though, right? Do I subtract? Like, is this a subtraction question? Remember that because it's in front, it actually by default has a positive sign. So when I'm doing the opposite, I must subtract a 7. So be careful. This is a tricky type of question here. A lot of people make a mistake on this. It takes a little bit of practice, but but you'll get used to it. So the opposite of plus 7 or positive 7 is negative 7 or minus 7. So then I can cross off the 7s, but I have to leave that negative symbol up. Now, what is negative 5 minus 7? Now, if I really want to do this properly, I could do negative 5 minus 7. Sorry, there's a little technical error there. All right, so divide by negative 3. All right, because this is negative 3 times x, so I have to do the opposite, which is divide by negative 3. And I have to do it to both sides. All right, so now the negative 3's, they cancel out. And so I'm left with x. And now on the right side, so remember for this kind of question, you start with the numbers. So 12 divided by 3 is 4, and negative divided by negative is positive. So I don't have to put a plus there, but that's the answer. X is already isolated, so I put the equal sign back in, and I have x is equal to 4, and that should be my answer. I'm going to double check. I'm going to put the 4 in right here on the top. So what is 4 times 3? 4 times negative 3, that's going to be negative 12 or minus 12. So 7 minus 12 is, well, look at that, negative 5. All right, so that is the correct answer. All right, so that was already pretty complex, but we're going to incorporate questions with factoring. Now, what's unique about these questions is that there's actually 2 ways of solving them. And so this really depends on what you would prefer and how you would rather answer this. There's no right or wrong way of doing it, and both ways honestly take just the same amount of time. So let's just go straight into some examples. I think it would work better if we just did it that way. So 2x, or 2 parentheses x plus 5. And let's make that equals to, let's make that equal to 30. All right. So we're going to do this in 2 different methods, all right? I'm going to write down method 1. Which is you do the expand. So 2 and then x plus 5. Let's rewrite that back in here. So 2x plus 5 is equal to 30. Now, if I expand, I can take the 2 and I need to multiply by the x, and I need to multiply that by the positive 5. So before I continue with the whole question, I'm just going to expand it first. So 2x plus, 10. All right, so that's what I have is equal to 30. Now that the factoring is out of the way, I can start doing the calculation the way I did it earlier, right? Because now you see that this is a lot more familiar. PEMDAS backwards, minus 10 on both sides, get rid of that. Left with 2x, 30 minus 20, minus 10 is 20. And then divided by 2 to cross that off. I'm left with x, and 20 divided by 2 is 10. So x is equal to 10. That's method 1. That's when you expand first. All right. So now let's compare it with another method. Now, if you have some room on the side, you could write it down on the side of your paper. If you are out of room, then just write it below. I'm going to write it beside just so I could show you how they're not really like more or less steps in a way. The second method is now you just do PEMDAS backwards, all right? So the PEMDAS backwards, let's write this question again. 2x plus 5 equals 30. Okay, so if we're looking at PEMDAS backwards, this is what you do. Remember that parentheses always goes first in a normal PEMDAS, which means this has to go last. So now I could actually see that this parentheses right here is something that I will not deal with right away. I'm actually going to deal with what's outside of that parentheses. So let's look at what's outside of the parentheses. Are there any addition or subtraction questions? There isn't, right? Not outside of the parentheses. So there's nothing on the AS, the addition subtraction. So let's look at the MD, the multiplication division. There is a 2 that's being multiplied by the x plus 5. So what I actually can do here is I could start by dividing by 2 first. So if I divide by 2, I do it to both sides. That eliminates the 2 on the outside. So now I'm left with x plus 5, and I could actually remove that parentheses because it's no longer bound by anything else, right? There's nothing outside of it, so I could get rid of the parentheses. Okay, so then 30 divided by 2 is 15. Oh, so now you see that I could actually just subtract 5 from both, and then I could get rid of that side, and so then I'm left with x, and I'm left with 10, and that is x is equal to 10. So you see how these two methods are actually about the same length. I guess one of them is a little bit longer than the other, but I did push it down, or I started the equation a little bit lower. But when you take a look at these two methods, you see how they both get the same answer, right? And oh, sorry about that. This should be method 2 right there. But you see how these two methods will get you the same answer as long as you do it mathematically correct. So when you stick with one of the methods, you do have to commit to it, all right? So I'm going to give you one more question here. And for this question, I would like you to try to solve this. Now I'm going to make it a little bit trickier. I'm going to have 1 over 6. And let's have the letter y plus, let's make it 18, equals, and let's make this side 2. All right, so I'd like you to try to solve that question, and if you want to pause, you can pause, and if you're ready to go, we can just go ahead and go for it. So I'm going to start with method 1. And so method 1 will be where I expand first. If you think you've solved this and you pause it, you could actually just jump to the end and see the answer to see if it's correct. All right, but if you'd like to see the steps, how I do method 1, I'm expanding it first. So I'm left with y over 6 plus, and then 18 over 6 equals to 2. There's a little bit of cleaning up here. So y over 6 plus, and then 18 over 6, I could change that to 3 equals 2. So now I should be able to solve this this way. So I'll do minus 3 first, and then I'm left with y over 6 is equal to 2 minus 3. So that's equal to negative 1. Then I'm going to times both sides by 6, because that's the opposite of divide by 6. And I'm left with y. And I'm left with negative 1 times 6, which is negative 6. Done. Can't do anything else. Fully isolated, y equals negative 6. So that's the method 1. Now, if you did it method 2, or you'd like to just see how I get the answer there, all right. So this one where I just jump straight into this. I start with the outside, which is the 1 over 6 multiplied. So I'm going to divide it by 1 over 6. I can cross that off. I'm left with y plus 18. And then on this side, it is 2 divided by 1 over 6, which is equal to 2 times 6 over 1. All right, times the reciprocal. So in other words, 2 over 1 times 6 over 1, or just 2 times 6, so that's 12. So I have 12 here. All right. So then I will subtract 18 to do the opposite on both sides. And then I can cross that off. I'm left with the y on one side. And then 12 minus 18 is equal to 12 plus negative 18. So now they're opposite sides, so they fight each other. I'm left with 6, and it's a negative 6 because the negative side wins. Nothing else I can do there. So y equals negative 6. All right, you could see that they're both the same answer there. And so I was able to get the answer with those two methods. So that's a little bit about this, solving equivalent equations. All right, that's it.